Well, hi! Here we are, and it's a beautiful day to think about astronomy. I'm preparing my little telescope for tonight so I can try to see some stars. It's supposed to be really clear. And what I want to do today is introduce you to a friend of mine named Caroline. She is a doctor of astronomy, and she studied for 5 long years to learn everything about space. But let's first understand, what is the telescope all about? What can the telescope help us understand? Faraway space helps us understand Earth better. And when we understand space, we can help understand more about the gases in the universe. We can measure them, and they help us understand how to monitor our air quality and improve it here on Earth too. And we can also find out from materials that we find in space. They can help us understand what we might have left to discover out there that could help improve our quality of life on Earth. And first of all, stars help us find direction at night. So that's what I'm getting ready to do today. And now I want to take you to meet my friend Caroline. I hope you'll enjoy meeting her. I wonder if you would share with us what has led you to study astronomy and what you hope to do in the future.
What first got me into astronomy was when I was a young child. I loved to go out and stargaze, to look at the stars. I thought they were so beautiful, and that really impressed me. And also I always loved, in elementary school, looking at beautiful pictures taken by telescopes, which are tools that astronomers use as well. Here we have some pictures from the Hubble Space Telescope of galaxies, and this is an object in our own galaxy in the Milky Way called the Crab Nebula. But they're very beautiful because of the filters that astronomers use. They take special tools which they put in front of the telescopes, which block out certain light and let in certain light. And when you place them together, these pictures, they make beautiful color images. When I think they're beautiful, and it really inspired me to get into astronomy. In order to go into astronomy, students should consider studying lots of science and math. These are really important tools for physics and astronomy. Studying physics is very important to get into astronomy, and studying math. So if you enjoy learning about how things work, why they work the way they do, if you enjoy playing with numbers, it is so much fun, and I encourage you to keep following those excitements. And if right now math is harder for you or not your thing, keep trying, because it is so much fun, and I know that you can get it. I know that you can understand it. Just look for different teachers, look for different friends who are excited about it. It's always possible to be good at science and math and to love science and math. And these are really, these physics and math classes are so important for astronomy. When I go to work as a graduate student on a typical day, when I was a much more junior graduate student, my first years, I went to class, I taught labs. But now that I'm a more senior graduate student, I come to my desk and I work on a computer for my research advisor. Astronomers' #1 tools are their telescopes. They go to telescopes to collect pictures and rainbows of light, spectra of galaxies, stars, planets in our solar system. That's their #1 tool. So here we have a small telescope that might be used in a backyard for an astronomer who wants to give a little bit of information to some scientists, or who wants to do astronomy for their own fun. Astronomers who are doing research would use a bigger telescope, but this is a small telescope that will show us exactly how telescopes work. So you might be looking at a distant galaxy far away in space and very old, looking at light from a long time ago. And that light will enter your telescope here at the top. The light will enter the telescope and it will hit a mirror here at the back of the telescope. This is what we call the primary mirror. Then the light will travel up inside the tube and it will hit a secondary mirror somewhere. The secondary mirror here is actually located at the front of the telescope as well. Then after hitting the secondary mirror, the light will travel back through the tube again and reach your eyepiece. And this is a place where the light comes into focus, into a perfect picture. And with some lenses in the eyepiece region, you can either choose to look through the telescope yourself to see the distant galaxies, or, as astronomers often do, you might place a camera here at what we call the focal point, at the place where all the light comes together. A camera here could collect the light to take a picture of the distant galaxy, or you could put a prism for a spectrograph to collect a rainbow of light, a spectrum of the galaxy. So whatever you're doing, looking with your eye, looking with a camera, looking with a spectrograph, you would place it here in the telescope. So the primary mirror brings the light to the secondary mirror. The secondary mirror brings the light to the focus, where the eye or the camera is located.
And then what is this? Because this almost looks like a phone.
Absolutely. This is perfect.
It is a phone.
This is the way to dial the phone number of your galaxy, or to figure out what galaxy are you trying to find and where is it located. What star are you trying to find and where is it located? Are you looking for Mars? Are you looking for Uranus? Are you looking for Saturn? You tell the telescope where to point with this little GPS device here.
As in what you were saying is that that's why they have numbers, as you were talking about.
Exactly right. In fact, just as here on Earth you may have heard of GPS, you can find any location on Earth with a number. We do the same thing for the sky. We have numbers that let us find where a star or a galaxy or a planet is located at any point in time. But their number 2 tool is a computer. Most of the work of astronomy is done on personal computers. And so in addition to studying science and math and loving science and math, loving computer sciences is also really important for astronomy. But I come in each day and I work on a computer with pictures and these rainbows of light, these spectra of, in my case, galaxies, and some of my colleagues, objects in our own Milky Way galaxy, stars, solar system objects, planets, comets, things like this. And I work with the data. I try to answer questions that we want to know the answer to. Every galaxy has a supermassive black hole, which is tens of millions of times the mass of our sun. Every galaxy. And you may have heard of black holes. You may think they're a little scary. Don't be scared at all. Black holes are not anything dangerous. They're very massive objects, much more massive than our sun. But just as our Earth orbits around the sun, no problem, it's not going to hurt us. Stars in a galaxy orbit around the central supermassive black hole. It's not a danger to the stars. There's nothing to worry about with a supermassive black hole. They're just a part of the galaxy. And we work to figure out how much mass do the supermassive black holes have. Yes, tens of millions of times the mass of our sun, but this galaxy over here, how massive is its supermassive black hole? Is it smaller than or bigger than the supermassive black hole its other location of the night sky? And we figure out what are the masses? How much do these supermassive black holes weigh? How heavy are they? That's another word for mass, another way to understand it. The incredible thing about astronomy is that it is very closely wrapped up in time and space relationships. When you go out and you look at the night sky, kind of as I did when I was a kid, and I do still, and I enjoy looking at the beautiful stars, the incredible thing is that you're looking at so much information in both time and space. These relationships are spread out before you when you look at the night sky. This is because the light from the stars, it travels very fast. But the issue is that the space that we see before us, the universe, is so large, and even light at this quick speed, thousands, hundreds of thousands of kilometers per second, hundreds of thousands of miles per second this light is traveling. It still takes a very long time for the light from these far away stars and galaxies to reach us here on Earth. And so if you look at the sky and you see stars, they may be 25 light years away. They may be hundreds of light years away. This means that light going at that quick speed still took 25 years to reach us. 100 years to reach us. The galaxies that I study, in particular, the galaxy that I study the most often, this galaxy, which is known as NGC 4151, a very silly name, it is 60 million light years away.
Oh my
That means
goodness.
that light at its quick speed has traveled so far, it has needed to travel so far that the light that we look at is 60 million years old. And so when you look at the night sky, the objects that you see are not only very far away, but the light that you look at is very old. The light left that star before you were born, before your parents were born, maybe even before any people were here on this earth. And we are just now seeing that light today.
Oh, that is so interesting. Well, we really have loved being able to let you share a little bit about what your passion is, and we've learned a little bit about the tools. And so if you have a chance to look through a telescope anytime soon, we hope you'll see some stars and be excited the way Caroline is. Thank you very much.